Chapter 5 takes the idea of simple probability and now tries to expand it to taking a look at what we had called in the past a probability distribution. Um, Now, probability distribution, you're going to notice that, first off, one of the things that makes this a little bit different is this word right here. So now we have switched to looking at discrete data, which we've talked about what discrete data is before, but let's do a quick review. So, first off, a random variable is a variable that basically has a numeric value. It's determined by chance, it's random, and it's basically representing the outcome. So previously, what we were seeing was our event was maybe rolling a die. Our random variables were the numbers 1, 2, 3, 4, 5, and 6. They were all and will continue to be discrete variables. Discrete variables, they are finite or countable. How many threes did we get? Or much more practically, how many calls were made by a telemarketer? Now, there's also, remember, a continuous variable. And these are the terms we've talked about before. The continuous variable has infinitely many outcomes. It is usually accompanied by a unit of measure. So if the number of calls made by a telemarketer is a discrete value, the time spent making the calls is a continuous variable because that would be measured in minutes or minutes and seconds or something like that. Okay, now to get a little bit more specific, then, and just to kind of practice it. So, if we were talking about the number of Fortune 500 companies that lost money, we would be looking at a discrete variable. And those are the types of variables that we're going to see in chapter 5. Chapter 6, then, you're going to see we're going to make a switch to a continuous. However, then number 2, the volume of gas is going to be measured typically in gallons, and that's going to be a continuous. So we might be looking at for probability, what's the probability that more than 300 companies or 300 Fortune 500 companies lost money? That's a discrete probability. Whereas a continuous variable probability is going to be, well, what's the probability that any randomly selected car in the parking lot has less than 10 gallons of gas in their tank? That's a continuous variable. Now, as we look at this in terms now of probability, we're going to be looking at it in terms of a probability distribution. So the probability distribution basically lists all of the outcomes, but more specifically, it's going to list the probability for each of the outcomes. So if we were talking about the dice, the probability of a 1 is 1/6. The probability of 2 is 1/6. And a probability distribution would list all of those outcomes, 1, 2, 3, 4, 5, 6, with their probabilities of 1/6, 1/6, etc. So there are three conditions for a probability distribution. First off, there's a numeric variable, and its numbers are associated with probabilities. I mean, that's just kind of normal. It makes it different than a frequency distribution. If you remember, frequency distribution had percents. This will have probabilities. The two that we want to be checking are these 2 points right here. First off, again, look at your notation. The sigma means sum, and then P of X stands for probabilities. And it's basically saying that if you look at a table and the sum of the probabilities is equal to 1, that's a condition met for probability distribution. Really, it just tells you that you have all of the possible outcomes with their probabilities. The other thing is number 3. Again, don't get too tied up in how this is written. This simply means that your probability needs to be between 0 and 1 inclusive, meaning it could be 0, could be 1, for every single value. Well, we know that because if honestly you try and you get a probability that's outside of that range, there's an error. Okay, so as we look at our first type of task, we're simply going to look at probability dis or distributions, well, or tables, and decide if they are probability distributions. So the first thing that's very easy to do is to check all of your probabilities. So I want to be looking at this particular row and make sure that they're all between 0 and 1. Yes, they are. So if you needed to justify it, all of your probabilities are between 0 and 1 inclusive. So then the next thing would simply be to check, is the sum of the probabilities equal to 1? So all I'm basically going to do at this point is add up all of these probabilities. So we're just going to pull out our calculator, add up those values. It comes out to 1.07. So does this describe a probability? No. Now, we've talked before about the fact that I like asking why, and it's no, really, right, because of that. The sum of the probabilities is not equal to 1, it's equal to 1.07. Okay? Okay, so then in the next one, I'm trying to decide, is it a probability distribution? Again, first step would be to check all of those probabilities, make sure they're between 0 and 1. Well, wait a minute, I've got two problems with that right here. All right, I've got a probability for the 3 that's over 1, and I've got a probability of 4 that's negative. So this would be a case where no, this is again not a probability distribution. What's happening is, or your reason, quite honestly, could even just be circling here because you're showing me that these are the two errors. Now, an example of something that is a probability distribution is actually going to be used in the next video. But we're going to start to create the probabilities as we go on. So we'll see more from this particular lesson in the next video. So stay tuned. Make sure that you do have your calculator kind of ready to go because that's going to come into play quite a bit as we go through some of the next couple of lessons.